together in ArcGIS and exported to as a Google Earth mashup. One of the concepts, I think, which is particularly critical here, and certainly resonates in the United States and more around the world, is the concept of spatial data infrastructure. And this is a concept which now dates back to the early 1990s and reflects, I think, a series of trends in society in the world of geoinformation. And it seems to me that national spatial data infrastructure was initiated partly because of the perception that the traditional system was breaking down. The traditional authoritative system, for a number of reasons. Number one, perhaps, because government, certainly in the United States, was less and less willing to fund the creation of geoinformation. The U.S. Geological Survey's budget has been declining for decades. The average map in the United States is now 30 years out of date. And yet against that, there is increasing demand, exponentially increasing demand for digital geographic data. And there's a perception that government cannot possibly keep up with the demand. More and more smaller agencies and even individuals are being empowered to create geographic information. And in fact, the cost of entry into the mapping business has essentially gone to zero. Using the examples I've shown you before, you can create geographic information essentially at zero cost. No longer do you have to invest in massive, large-scale printing systems, in analytical stereo plotters, in all of the apparatus of map making, because all of that has simply been bypassed. And what this led to, of course, is an abundance of data sources, and in effect a reversal of the flow of geoinformation from the traditional top-down to bottom-up. And that's the world, I think, in which this BGI phenomenon is emerging. There's a 1992 report from the National Academy in the US about the national spatial data infrastructure. President Clinton signed an executive order in 1994, and all of this momentum has been running now for almost 20 years under the Federal Geographic Data Committee, the Open Geospatial Consortium, etc. So that, I think, provides some of the background for what I'm talking about. Let me step back a little and ask what makes this possible. What are the technologies that are supporting BGI? And of course, Web 2.0 is one of them. Web 2.0, a very broad term for a domination of the web by user-generated content. So the world of wikis, the world of blogs, the world of information contributed by users. No longer is the web a one-way flow of information, downloading information. It's now a two-way flow. I think it's important also to emphasize the significance of the web's search engines. Think of a world without Google, or without Yahoo or any of the competitors. Because it's the search engines that make it possible to find all this stuff. If I were to Google, for example, Jane Austen Google Earth, I would immediately find a wonderful mashup, I'll show in a second, of all the works of Jane Austen in a Google Earth context. But there's an important issue here, which is emerging quite rapidly, I think, which is the question of the power consumption of the Google Earth, the Google search engine. Google currently runs on the order of 1 million computers to support its search engine. Google is starting to behave like an aluminum company, searching the world for cheap power. Because the power it requires to run those 1 million computers is becoming enormous. Important question then is, how long will Google scale? How long will it be possible to very rapidly get a very complete analysis of all of the sources on the web which relate to a particular topic? Do we have 5 years? Do we have perhaps even less? That, I think, is one of the more important issues here in terms of long-term trend. Here's the wonderful Jane Austen mashup. You can go to any one of these icons, zoom in, and you can find all of the places that are mentioned in the novels, or all of the places that were used to film the novels, etc., etc. Another technology, I think, which is critical here is georeferencing, because all of these BGI efforts require the ability to determine location quickly and easily. And very few people know their latitude and longitude. Very few people would be able to answer this question: what is at this particular location? Or even this question or this question: But certainly many people would be able to answer this question. The answer to all 4 questions is the same. It's my house. But this one, of course, the ability to convert very quickly between a street address and a latitude-longitude is what underlies a lot of these technologies. If it weren't possible, then it would be very difficult for the average person to enter, to create geographic information. Many people read coordinates from Google Earth, and I'll come back to that in a moment. And of course, many people use GPS. So it has become trivially easy to determine accurately the position of anything on the Earth's surface. And that's one of the technologies which is driving BGI. Another is service-oriented architecture. And the notion that information flowing around the web, dynamic information, can acquire value by being processed by different sites, by various services. And the 2 services which have been particularly successful to date in the world of geoinformation are geocoding and gazetteer lookup. So there are now numerous sites around the world where you can quickly convert a street address to a latitude and longitude. That's made it possible for a BGI to be created quickly and easily. And it's also made mashups possible, because mashups essentially rely on being able to create new information by linking together old sources. And let me just give you a couple of examples. This is a project called AGIT, Advanced Emergency GIS, sponsored by ESRI and by the Loma Linda University Medical Center. And it consists essentially of a situation room or situation website for emergency management. On the screen are various icons, and each of them reflect dynamic information. So this icon here, for example, which is a helicopter, is the real-time position, updated every 5 seconds, of a rescue helicopter. This is a real-time position of a fire truck. This icon here for a hospital, if clicked on, would give real-time information about the state of the emergency room in that hospital. And here is a camera on a freeway, and clicking on the icon simply brings up an image in real time of that area. To do this, of course, requires mashup. It requires web services. Here's another application. This was during the wildfires in California last fall, and these are the real-time perimeters of several fires that were burning at that time, with, again, real-time resources. What's happening here is that GIS, geoinformation, is moving into real time. And it's moving into real time through service-oriented architecture and mashups. So here's a schematic of what's going on here. There are approximately 20 sources of information, all of them available on the web, but using various standards and requiring various amounts of processing. So some of them, for example, which give information by street address, have to be processed through a geocoding service before they can be integrated. Others are relatively stable and relatively straightforward. Each of them is polled at an appropriate frequency, ranging from 5 seconds to a month. And the result is made available to any number of users who need access to this picture of the emergency. And of course, the interface allows us to zoom in, pan, and select and click on relevant information. Here's another. I'm very amused by this. This is an artifact of the reality in the United States